Hello everyone. Let's try to understand Cannizzaro reaction. Now we have already studied aldol condensation and cross-aldol condensation. So from the previous videos, you might make it out that aldol condensation and cross-aldol condensation have one important or we can say mandatory requirement for a reactant. There needs to be an alpha hydrogen present in the reactant. You might take any reactant, no problem, but it needs to have an alpha carbon, it needs to have an alpha hydrogen. The same thing is reversed in Cannizzaro. Okay. In Cannizzaro, there need not be any alpha hydrogen. So you're going to point out to such reactants which are missing an alpha carbon, which are missing alpha hydrogen. Basically, what happens in Cannizzaro, you take an aldehyde, you're simultaneously going to oxidize it and reduce it. We know one thing for sure, whenever an aldehyde gets oxidized, we get a further addition of oxygen, that is carboxylic acid. And whenever an aldehyde gets reduced, we get an alcohol. This is the basic principle. So we go from alkane, alcohol, aldehyde, carboxylic acid. That is how oxidation works. So one step ahead of oxidation of aldehyde, carboxylic acid. You take one step back, you get alcohol. So Cannizzaro is nothing but a fancy name given to redox reaction of aldehydes, where simultaneously the reactant is being oxidized as well as reduced. Okay, keeping this in mind, let's try to hunt for reactants which are missing alpha hydrogen. For that, I've taken a set of, let's say, 4 examples, and let's see whether we can find alpha hydrogen or not. Now here, this is your functional group, correct? We'll just mark out the functional groups first. In the second reactant, we can find functional group to be here. Third reactant, functional groups here. And the fourth reactant, we have it over here. What is our logic that the carbon which is adjacent or next to the functional group is called as alpha carbon? So the first reaction or reactant has an alpha carbon. That means it also has alpha hydrogen. And what did I tell you? Cannizzaro, no alpha hydrogen. So we cannot take this reactant in Cannizzaro. Let's see in the second reactant, this is the group, functional group, but there is no carbon beside it. No carbon meaning, yes, alpha hydrogen is missing. We can take this for Cannizzaro. Third reactant, if you see, functional group, next is alpha carbon. Now, mind you, alpha carbon also is having alpha hydrogens along with it. We do not require that in Cannizzaro, a big cross. We don't need it. Fourth reactant, if you see, yes, we do have an alpha carbon. But issue being, how does this look like? How does benzene look like? Let's see first. I'll just try to make this bigger so it becomes pretty visible. Okay. So let's say benzene looks something like this. So we have 6 carbons and each of the 6 carbon is attached to 1 hydrogen. Okay, so each carbon attached to 1 hydrogen. Correct? And on one of the carbons, we have an aldehydic group present. So this is a functional group. So yes, we do have an alpha carbon over here, if you notice. We have an alpha carbon over here. But problem being that every other carbon has only 1 hydrogen. And this alpha carbon initially had a hydrogen, but it got replaced with your aldehydic group. So now if you focus on this alpha carbon has no hydrogen attached to it. So in this particular reactant, yes, there is an alpha carbon, But this alpha carbon does not have an alpha hydrogen with it. That's why we can consider this for Cannizzaro. So which two prominent reactants we can consider? One is called as formaldehyde, right? Or if you go according to IUPAC nomenclature, we can also call it as methanol. Methanol itself has only one carbon, and that carbon is utilized as a functional group. In your second reactant, which we can take, this is benzaldehyde. Benzaldehyde. So only two reactants possibly can be taken for Cannizzaro, which do not have any alpha hydrogen, one being methanol, another being benzaldehyde. So let's try to understand Cannizzaro using the first reactant, methanol. Okay, methanol or formaldehyde, we are going to utilize this particular reactant first in a basic medium. So what do? We take, let's say, 10 ml of methanol or formaldehyde first, and then we add it in a basic medium. What happens when we add it to a basic medium? First things first, as soon as we add it to the basic medium, we need to know here we have an hydroxyl ion, and hydroxyl ions are pretty reactive. What would they do? They will convince the carbon to shift its double bond over oxygen. So it will make the carbon remove the double bonded oxygen and free itself. So it frees one hand and makes sure that the oxygen gets a negative charge. So what is your hydroxyl ion doing? It is breaking open the double bond of the carbon and oxygen and freeing one hand for attachment. Let's see how it looks, right? So the double bond was broken by the hydroxyl base and it opened up a bond for OH to come and attach. Now, what do we know? That oxygen initially was stably double bonded, but because now it is single bonded, it has negative charge or lone pair of electrons hovering over it. So this is an unstable structure, right? It's not a stable structure. We have O minus lingering around. What happens as soon as we add this to the base and the reaction completes? We are going to add another set of formaldehyde. Okay, so technically 1, 2, we add our reactant twice to the reaction. Why are we doing this? So for this, you need to understand oxygen is doing what? Oxygen has become unstable. It has got its negative charge. It would try to bring back its stability by forming a double bond. So what will oxygen do? It will try to make a double bond again. And in that bargain, carbon can't have 5 bonds with it. So it will try to release one hydrogen out. What is happening? Oxygen O minus unstable. It tries to regain its stability by double bonding with carbon again. Carbon in the meantime gets 5 bonds. 5 bonds are not applicable to our carbon. So carbon will release out hydrogen. Why hydrogen? Because one side there is a double bonded oxygen, another side there is OH. Both are strong groups. Carbon won't, hesitate to remove a smaller group like hydrogen. Bichara hydrogen has no place to go. Where will it go? It will try to disrupt somebody else's family. It will go to this carbon. And what will it do? It will say this carbon, see, I have come. Please try to accommodate me. And in that bargain, carbon is going to release its bond, make oxygen negative, and open up some space for hydrogen. So see, so many things are happening simultaneously. Oxygen became stabilized using double bond. Hydrogen got released. Hydrogen went to the next formaldehyde, asked for some help. Carbon shifted its double bond, opened itself, gave some space for hydrogen. And in that bargain, one of the oxygens got again negatively charged. So can you see, same thing is happening. What base OH did over here, hydrogen did on the other formaldehyde. So what are the expected products over here? You got your perfectly formed acid ready. And on the other hand, you have a particular structure where there is O negative or unstable oxygen. What do we do next? We again add base. When we add base, we are going to get OH minus or hydroxyl ion. And we know what hydroxyl ion can do, right? It is known to make some changes in the bonds. Here, the hydroxyl ion can see, this is an acid form. And acids are known for what? For donating their protons. So oxygen would do what? It would donate the proton. And this proton along with hydroxyl will form water. Why only from acid? Why not from the second structure? Second structure has 3 hydrogens, right? But why not from the second structure was the hydrogen equipped? It is because the first structure is an acid. And acid is known for donating the proton. Now just imagine proton has been donated, water has been formed. What would then become the charge on oxygen? It will again become negative. So what are the probable products? You get your oxygen again negative. Okay? You get water formed and this particular product remains as it is. Okay. First step, add a base, shift the double bond, open up side. Second step, add the proton on the other reactant, double bond shifts up, side opens up. You again add a base, you're going to remove water, and that is how we have reached the step number 3 completely. So how do we remember? This is something that I use, a cheat sheet. Step number 1, you add OH. Step number 2, you shift hydrogen. Step number 3, you add OH again. Okay. So this is how you should remember. Now mechanisms hardly are asked in examination, but it does not sweat out to remember how things work. Okay. Now this is our product. We have got it. We have got our final answer. Now let's see how to stabilize it. To stabilize it, the hydrogen from the water is taken up by this negatively charged oxygen. So can you see when hydrogen is taken up, your OH gets liberated. How things work? You get an acid, okay, and another one you get an alcohol. And if you see your OH or your hydroxyl ions have been regenerated. It's always important in multi-step reaction to save up the cost, okay? You need to make your steps in such a way that the original catalyst, base, whatever protons you're using, that some or the other way gets regenerated. If it's getting regenerated, meaning you have an economically stable industrial process. Because then you need not waste your time adding a lot of reagents. You can only focus on adding the reactant. So whenever you see in multi-step reactions, some things are getting regenerated. They are actually very good reactions economic-wise. Okay. Now, over here, if suppose you have used NaOH as a base, you might get your acid as sodium salt of methanoate. Okay, or sodium methanoate. Okay, this is nothing but your sodium methanoate. We also call it as sodium formate. But let's stick to methanoate. Okay, so this is an acid. We have an alcohol generated. So what has happened actually? Of the 2 aldehydes that we used, one aldehyde got oxidized and formed an acid or salt of an acid, and the other aldehyde that we used got reduced into alcohol. Okay, if in examination they have directly asked you, show us or give us what probable products would be formed, you can skip all the mechanism and directly jump on to this final step. If they are asking for mechanism, I've already told you the steps. The steps become extremely important. If you have understood this, try to, write it down in your notebook without looking on the screen or taking help of the reaction given. If you're able to, try out another reactant that I can tell you, the second type of alpha hydrogen or no alpha hydrogen reactant, that is benzaldehyde. Try to react the benzaldehydes in the presence of KOH as a base. So instead of sodium salt, you might be getting potassium salt as an answer. So one of the benzaldehyde will become, you know what? Okay, and another benzaldehyde, you know what? Okay, one would be oxidized, another one would be reduced. Try to use the mechanism. My bad, I have given just one bond over here, it's double bond. Okay, I hope you have understood the mechanism of Cannizzaro. Again, you can make the speed into 2x, go through it, revise quickly. All the best. Meet you next time. Signing off. Bye.